G'day guys. Alright, let's jump straight into it. For this lesson, we're going to be continuing on from what we were doing last lesson, which was finding the equation of a straight line, except that we're looking at a slightly more complicated scenario today. Last lesson, we were looking at the scenario where you can easily see from looking at your graph what the y-intercept is, which means you get your a value for free in y equals a plus bx. Okay, you just look at the graph. That's not always that easy. Okay, sometimes your graph will intersect the y-axis through a point whose y-coordinate you can't clearly tell just from looking at the graph, you know. And sometimes you won't actually be given a graph at all. You'll just be told, you know, find the equation of a line that goes through these two coordinates. You're not even given a graph, you're just given two coordinates, okay? So using this method that we're learning today, you can find an A, a B, and therefore an equation. All right, so let's just dive straight into a couple of examples. Determine the equation of the lines in the following graphs. All right. So let's do A first. The first thing we're going to do is we want to identify 2 points on our graph. Any 2 points will do, but we want to be a little bit clever about it and try to identify 2 points that have whole numbers for their coordinates. Now, this won't always be possible, but the way that the textbook, and all textbooks, in fact, write these questions means it's usually possible. Okay, in the real world, if you have a linear graph, it's not always going to be possible to get 2 points with whole numbers for coordinates, but for these sort of pre-made textbook questions, it's usually possible. So if we look carefully, we can see, there's one. That's 5, 3, 5 units to the right of the x-axis and 3 units up the y-axis. And, oh, here's another one. That's 1 unit to the right on the x-axis and 5 units down on the y-axis. Good. Now what we're going to do is label these 4 numbers x1, y1, x2, y2. There we go. Now, just like we discussed last lesson, you absolutely could have labeled these 2 numbers as your x1 and y1, and these 2 numbers as your x2 and y2. It doesn't make any difference, okay? If you do follow the process correctly, you're going to get the same answer no matter which way you do it. All right, so now we're going to use those 2 coordinates and the gradient formula to determine the gradient. So here we go. Gradient B equals y2 minus y1 over x2 minus x1, which equals, well, y2 is 3 and y1 is minus 5. So y2, 3 minus y1, which is minus 5. So see how we get 2 negative signs? A really common mistake there is just to write 3 minus 5. But it's y2 minus y1. y2 is 3, y1 is negative 5, and it's 3 minus negative 5. y2 minus y1. All right, so you get 2 negative signs next to each other. Over x2 minus x1. So that's going to be 5 minus 1. Okay, 3 minus 5 becomes 3 plus 5, which is 8. And 5 minus 1 is 4. So we get 8 over 4, which is in fact 2. So there we go, we've found the gradient. The gradient is 2. All right, so that's half the picture. Now we just need to find A, the y-intercept. All right, so what we're going to do is the following. we are going to select one of our 2 points. Either one will do. I think I'll just choose this point right here for no particular reason. And using that x value and that y value in combination with the gradient value that we just found, if we substitute all 3 of those into the general equation for a straight line, y equals a plus bx, we can solve that for a. So here we go. Substitute b equals 2, x equals 5, and y equals 3 into y equals a plus bx. All right, so let's do that. Y is 3, so we get 3 equals a plus b times x. Well, b is 2 and x is 5, so 2 times 5. That becomes 3 equals a plus 10. And now to get a on its own, we need to subtract 10 from both sides of this equation. All right, so 3 minus 10 gives us an a value of -7. All right. Therefore, now we all have to do is replace the a and the b in the general form of a linear equation y equals a plus bx. Replace the a and the b with the a and b values that we found. Just substitute them in. So y equals -7 plus 2x. Nice and easy. Let's do one more example. All right, so let's do a second example. So here's our graph. Now the first thing we want to do is identify 2 nice points. So this looks like a nice point right here. Coordinate 2, 2. And I'm going to label those 2 numbers x1 and y1. Now I need a second point, preferably one that will have whole numbers for coordinates, just to make the mathematics a little easier. Here's one. That is -4, -1, which I will label as my x2, y2. And now I'm ready to dive in and find the gradient. B equals y2 minus y1 over x2 minus x1, which equals, well, y2 is -1 minus whatever y1 is, which is 2, over x2 minus x1. Well, x2 is -4 minus x1, which is 2. So we have -1 minus 2, which is -3, over -4 minus 2, which is -6. So -3 over -6 simplifies to 1 over 2, a half. Lovely. All right, now using the exact same technique as we did for the previous question, we are going to substitute b equals a half, gradient equals a half, x equals something, and y equals something into the general form of a linear equation, and then solve for a. So for my x and my y value, I have a choice. I can choose my x1, y1 pair or my x2, y2 pair. I think I'll just avoid negatives so as to make it less likely that I'll make an error, and choose the x1 and the y1 pair, but it doesn't really matter. So I'm choosing x equals 2 and y equals 2. So I'm substituting those into y equals a plus bx. Oh my god, you're going to have to forgive my messy writing. Still trying to get used to this stylus. Alright, so y is 2, which equals a plus bx. So a half times 2. Okay, now that becomes 2 equals a plus 1, because a half times 2, 2 halves is 1. Now minus 1 from both sides to get a will give us a equals 1. Now all we do is substitute a equals 1 and b equals a half into y equals a plus bx, the general form of a linear equation, and we get y equals 1 plus a half x. Boom. And that is that. Awesome. Thanks, guys. I'll see you next lesson.